So now we're going to approach a really important rule in integration. It's basically the chain rule for integration. It's called use substitution. We use it whenever you're integrating a composite function. That means you have one function inside of another. So normally we just integrate, hey, we got a function f of x here, and you just have a variable x inside of it. No big deal. You take the antiderivative, good, you're done. As a matter of fact, this would work whether it's the letter f or if it's some other letter. No big deal. I gotta tell you, it even works for the letter U. Is that a coincidence that this is called use substitution? I think not. First, let's digress a little bit here and go back to derivatives for a moment. When you have a happy little composite function, sine, and x squared, we have a quadratic inside of a trig function. We know that you take the derivative of the outside function times the derivative of the inside function. Now you can set this up. We could have rewritten this and said, look, we've got y is equal to sine of something. And what is that something? We take the derivative of each side. Cosine of u, du dx is 2x. When we multiply these together, we get dy dx, cosine of the original function u times the derivative of u. Not bad. We've done that before. Hey, if that's the derivative, we know that when we integrate that derivative, we should be right back to the original function, or at least once you've integrated, right back to the original function plus c, plus a constant. Constant might be 0, maybe it's exactly the same, but. So what's all this mess with? So I've got cosine, I know the integral of cosine is sine, but then what is all this extra bit here? Well, we're gonna do a little bit of substituting. Substituting is so important when you get into higher levels of calculus, and we're going to do lots of substitutions, multiple substitutions, excuse me, at some point. But watch what happens. So I've got this exact same problem here. We're trying to figure out exactly what is this going to be. Did I just write that wrong? Oh, I think I just made up a different problem, but nonetheless, we'll go along with it. What is the inside function? I have a composition, one function inside of the other. We're going to find u, just like we did when we were using the chain rule. However, now when I substitute, take the derivative of whatever you assign u to be. What is the derivative of x? The derivative of u with respect to x is 2x. So that lets me see that if I rearrange this just a little bit, dx is going to be equal to du over, I can write 2x. When I rearrange this, I multiply both sides by dx, divide them both by 2x. Watch what happens. I can rewrite my integral and make it much easier. We said that x squared was equal to u. And we said that dx is equal to du divided by 2x. By the time I'm done sorting this out, the 2x's are going to divide out. Now I've got a function with just a different variable there. This is a super easy integral. The integral of sine is negative cosine. So it would seem like I'm done, except, you know what, originally this was written in terms of x, wasn't it? What I would like you to do right here is back substitute. So if we start our problem with the variable x, I want us to finish this problem with the variable x. U, from what we said, is equal to x squared. If I back substitute, I have a final solution there. And that is how we do use substitution. The whole point of this, you have a difficult problem, a composition of functions. You want to find a way to rewrite it to make a much simpler problem.